Hi, and welcome to the Frog Pond School of Design, where we enjoy talking about things that hopefully appeal to the architect in all of us. Today, I want to talk about acoustics. Now, I've always felt that acoustics was one of the most overlooked aspects of architectural design, and it has such an effect on the success of every project that it really deserves a lot more attention than it gets. This is probably an oversimplification, but there are two basic types of acoustics in architectural application. There's sound control and there's room acoustics. So let's look at each one of those. Sound control is pretty straightforward. You've got sound someplace you don't want it, and you want to keep it from getting where you don't want it. You keep it where it belongs. And maybe it's good sound, but you, again, want to keep it from going someplace else. Unwanted sound is the definition of noise. So we're trying to control noise. Now, if you've got traffic or other outdoor ambient noise that you want to keep out of a building, that's pretty straightforward. You beef up the walls, you've got the exterior walls. The problem then becomes the openings, the windows, the doors, etc. And there are ways of treating those. So, you do what you can to keep the sound where it is and keep it from getting where you don't want it. And once you get inside in a room-to-room situation, you've kind of got the same condition, except that now you've got to do something special with these walls. Because most interior walls aren't built really to keep sound from going through them. And there are a couple rules here. First off is it needs to be airtight. So you build a wall, you seal it at the perimeter, you seal like outlets and that sort of thing. You've got to think of sound completely differently than you think of temperature. When you insulate a wall to control temperature, you can insulate that whole wall, and if there's a space that's not well insulated, it's going to affect the overall performance, but it'll still be pretty good. Sound is completely different. If you can do all you want to 90% of that wall, and if you ignore an opening someplace, that sound's going to go through there. All of it's going to go through there eventually. Think of it as a hole in your bucket. It doesn't matter how big or how small the hole is, everything's going to go through it. So you do have to be careful with these. And one thing in interior situation that's particularly vulnerable are in commercial applications that drop ceiling, because those critters are notoriously poor at stopping sound. And if the wall doesn't go all the way up to the structure and be sealed against that, just like it is at the ends, the sound's going to go through that ceiling, over it, back down on the other side, and you've got really no control. Room acoustics now is a whole different situation, and it can get pretty involved. You want to control the noise that's generated from within the room. You want to create privacy. Think of an open landscape office where people are working in cubicles, and there's nothing to stop the sound, so you have to do other things. The noise level itself isn't really the problem. The problem becomes understanding conversation. And acousticians can tell you, if you understand 3 words out of 5 or 2 words out, whatever it is, then that becomes a distraction, both because you're trying not to listen to it, and because you start to think, well, how much privacy do I have when I speak? And it becomes a kind of a snowballing situation. So the problem becomes one not only of minimizing the sound that travels, but minimizing the ability to understand it. And this is where like white noise, masking noise, and that sort of thing comes in. And think of yourself also like in a crowded restaurant. You can hear everybody around you, the noise level's high, but you can't understand the person across the table from you. This is where absorption comes in. You got to put it in the right place. For instance, in a lecture hall, you want to hear and understand that lecture. So you only want to hear it once. If you don't have proper treatments on the sidewalls and the back and the ceiling and the floor, you're going to hear it straight from the speaker, you're going to hear it bouncing off all, and the trouble is you don't hear them all at the same time because the travel distance is greater. So it becomes garbled and difficult to understand. You want to really get an example of this, think about churches where you've got a huge space, you've got things bouncing all around, and it's complicated by the fact that you both want to understand the speaker and the music wants to sound good. And these two things need totally different conditions. So that becomes a real particular design issue. So when you're laying out a room, you need to think about its specific requirements, what it needs to do, and if it's very complicated, get an acoustician involved or learn a little bit more about it yourself, because most acousticians I know are actually like structural engineers, because acoustics and vibration are really the same science. And it can get very involved, and there are applications that really deserve the expertise, but even normal everyday buildings and spaces can benefit from giving it some extra thought and paying attention to those things. So thanks for joining us today at the Frog Pond School of Design. I look forward to seeing you hanging around the pond again real soon.